Welcome to my farm. My name is rlsatz. This video will explain several performance advantages that this frame configuration offers. What you have just observed is a giant step forward for ag planters and strip tillers. The information I am going to show you about yield loss caused by compaction is based on many years of field test data that we did at Caterpillar. This planter has a typical front fold frame and typical tires of all of the major brands, so what I have to say here is not in any way picking on Kinsey. The nomenclature on these center tires says 14 ply and 105 psi. Both of those tires will cause compaction in the field for this 16-row planter. Let me give you a rule of thumb about the yield loss for these various rows. This row here is what's called a pinch row between the two heavily loaded tires on the back, and as a rule of thumb, this is a zero profit row. At one point, we conducted tests to determine what the pinch row effect was for tracks if a track straddled the planted row after the row was planted. We worked with Precision Planting, and the conclusion of their test was that if there is a gap 8 inches wide and 2 inches deep in the center of the belt, and if the bar to gap ratio, as I recall, was 1 or greater, that they could not detect any yield loss in the pinch row compared to the other rows that they picked one row at a time. This frame has a rear steer which is auto rear steer, and the GPS sensor is located directly above the row units, as you can see in this picture. So when this is equipped as a strip tiller and producing strips in the fall, the strips are precisely located. Whether you are doing a AB straight line or whether you are on the other end of the spectrum doing an S-curve, strip tilling has a low carbon footprint. Strip tilling leaves much of the ground cover in place to help prevent erosion. Government regulators are very apt to legislate in favor of strip tilling because of the low carbon footprint and low erosion. When I ask the largest farmer in my area why he does not strip till, I got a 3-word reply: too much hassle. Strip tilling needs lateral precision for all situations. Situations currently difficult to cope with include lateral skid of the implement and the S-curve. Auto rear steer is needed to easily handle these situations. Another part of the hassle is finding skilled operators for seasonal work. This frame configuration is compatible with low-skill, inexperienced operators mainly because of auto rear steer. This frame configuration and its features, when hooked to the modern tractor, is almost autonomous. Using this frame configuration for the strip tiller allows for 15 tons of fertilizer to be carried directly above the tracks. The heavy fertilizer load does not tax the tractor's hydraulics to raise and lower a heavy load because only the toolbar is raised and lowered. The seed and fertilizer containers on this frame configuration are always in a low position, directly above the tracks. Over the years, the modern planter row units have more and more delicate components located near ground level, such as seed firmers, electric eyes, and more recently the 10-mile-per-hour seed tube belt. Lowering the row units onto the ground at 0 forward speed is currently a common practice because it lowers the seed containers or fertilizer containers for easier filling. Lowering the row units onto the ground at 0 forward speed may cause the delicate components to land on a dirt clod or on a rock or on last year's stubbles. An added benefit of keeping the row units raised during reloading the center fill containers is easier inspection of the row units during the refill process. This frame configuration has characteristics of a motor grader's frame. The motor grader's frame configuration allows for precise control of its blade. Both this frame configuration and the motor grader have an arched mainframe. Both have a secondary frame that pulls the blade or toolbar. Both have front and rear steer. Of course, the tractor is the front steer for this frame configuration. This frame configuration uses a wheel to follow the ground profile. The planter and strip tiller's electro-hydraulic control system follows a ground profile somewhat like a combine header height control system follows the ground profile. This toolbar uses 3 ground profile sensors, one at each end of the toolbar's wings and one at the center. The ground profile sensors convert the ground profile into an electric signal, as does the combine header height control system by using potentiometers. Therefore, the toolbar height is controlled with a system similar to the combine header height control system. A difference is the ground profile is defined about 4 feet in advance of the row units for this frame configuration. We know that cars have headlights and windshields, so we can see the road in advance and react as needed. At 10 mph planning speed, the row units will normally react violently when crossing narrow, deep ruts. Crossing narrow, deep ruts are part of the strip till hassle. These narrow, deep ruts tend to form by erosion during the winter and early spring. 3 features. 1, the 4-foot advance notice. 2, the electro-hydraulic toolbar height control. And 3, the electro-hydraulic downforce system allow the row unit to be carried across ruts and not suffer a 10 mph jolt to its sensitive components. Tracks will bridge narrow, deep erosion ruts. Thus, tracks will help eliminate the hassle. The upper platform is for accessories such as air compressor, alternator, vacuum fans, pressure fans, junction blocks, electrical panels, etc. The fold-up ladder makes the upper level easy to get to. On this large upper platform, there is ample room for a diesel genset, sized as needed. There are incentives to change the many power-hungry rotary mechanisms on board the modern planter and strip tiller to high voltage and low amperage, and use small diameter flexible power cords. Electric drive would eliminate a lot of hydraulic hose clutter and some of the electro-hydraulic valves currently used. What you saw was the new configuration crossing a mud puddle. You might notice that first the row unit crossed and then the track crossed. This is a significant performance improvement that this frame configuration offers. In the spring, when 99% of the field is ready to plant, you've got 1% wet ditches, but you would like to cross that wet ditch. So this frame configuration is very good about how the planter negotiates a wet soft ditch. That is that the row units and the toolbar cross first and then the tracks cross second. Typically on the conventional planter frame configurations, if you're crossing a soft area, heavily loaded wheels and the row units go into the soft area at the same time, and the planter tends to sink and maybe gum up the works. The ground sensing wheel, first of all, will tiptoe across the wet ditch because it only carries 5-10 pounds of load, and that the row unit will not sink into the soft area. It ends up that the row units don't need to get gummed up in the process of crossing a wet ditch,